Okay, so let's talk about some of these properties of these rational functions, things that we want to know property-wise about them. And we'll just go one by one. Let me run down the list. I'm going to use my highlighter here to identify the things that I'm talking about. So the first thing is this. We say that a function f, this function f is 1 to 1 with a domain of all real numbers and a range from 0 to infinity. Now remember, we are talking about the basic function f of x equals b to the x. So in our basic exponential function, we are saying that it is always, first of all, a one-to-one function. So if we were to try and draw a horizontal line through our function's graph, at any point we would only cross in only one place. The domain is all real numbers. So if we're looking for these kind of graphs, we'll notice that as x tends towards negative infinity or as x tends towards positive infinity, the graph of f of x is always defined. And that goes for no matter which way this curve actually goes. Okay. Here's another one, very interesting. We say that the graph of f is a smooth continuous curve with a y-intercept at 0, 1, and the graph passes through the point 1b. Well, what does that mean? If we look at this graph, we can note just two things always happening all the time. Number one, the graph passes through the point 0, 1. Right? So whatever the base is, when we set x equal to 0, we get y equals 1. Well, that makes sense, right? That is a property of all exponential functions because b to the 0 is always equal to 1. Therefore, the graph passes to the point 0, 1. Another very important property is that when x is equal to 1, y is equal to b. So this graph right here and this graph right here will always pass through the points where when x is equal to 1, y is equal to b. And again, we go back to our basic property of exponents that b raised to the 1 is always equal to itself. That's a very important one. Now, I could throw in another one just for our own reference. So we could say that b raised to the negative first power is always equal to 1 over b. And so we would see that this would certainly be the case in each of these cases right here. This is actually a graph of y equals 2.7 raised to the x right here. And if I were to find what happens at negative 1, well, my y value would be 1 over 2.7. And right over here at x equals negative 1, y would be 1 over negative 2.7. So that's kind of just some helpful things to remember there as far as those are concerned. Okay, here's another one. If b is greater than 1, if the base is greater than 1, then the function is an increasing one, and the negative x-axis acts as a horizontal asymptote. Look at what's happening here in this first function, which I've highlighted, y equals 2.7x. The base is greater than 1, and all we're saying is that as x tends towards, let me get my pen out, as x tends towards positive infinity, as we go to the right, y tends towards positive infinity. But as x tends towards negative infinity, to the left, y tends towards 0. The graph approaches the x-axis. In other words, we have a horizontal asymptote at the line y equals 0 to the left-hand side of the graph. Now, on the other hand, we say that if b, oops, I don't want that to happen. Undo that, there we go. We say if b is a number somewhere between 0 and 1, then the function is decreasing, and the positive x-axis is a horizontal asymptote in this case. So what does that mean for us? Again, let's take a look at this function right here. We say that as x tends towards the left, as x tends towards negative infinity, y tends towards positive infinity. And as x tends towards the right, positive infinity, y tends towards 0. So in this case, you can see that we have a function that has a base that is less than 1 in this case. And so we have a horizontal asymptote along the line y equals 0, only this time to the right. So if we're looking at these two functions, these are some of the items that we should be looking for. All right, well, let's put this in context with an actual function. So let's say we're asked to sketch the graph of f of x equals 2/3 to the x. Be sure to label the graph completely and identify at least 3 coordinate points and the location of a horizontal asymptote. So let's take a look. In this case, I'm going to go ahead and make a table. And I want to choose 3 principal points. And we actually have already identified one right away. We know that when x is equal to 0, a property of this function is that this is the kind of graph that will pass through the point 0, 1. And we can check that out. F of 0 is equal to the base 2/3. It doesn't matter that the base is 2/3 or any other number. Any base other than 0 raised to the power 0 is equal to 1. Also, when x is equal to 1, y is equal to 2/3. Again, this goes back to our property that states that if we put 1 as the exponent to the function, 2/3 raised to the first power is equal to 2/3. Which I'm going to estimate probably over here somewhere. We'll get that. I also like using -1 as a value for x, because when I put in -1, let's take a look at what happens. F to the -1 power means that we're going to be taking the reciprocal of whatever our base is. So we have a base of 2/3 raised to the -1st power. Our result will be the number 3/2. Kind of interesting. That's what should happen right here. But let's plot it on our graph. Our graph then says at -1, y is equal to 3/2. Right about there. At x equals 0, y is equal to 1. And at x equals 1, y is equal to 2/3. Well, that seems kind of reasonable right here. Let's just choose a couple of points just to see what else will happen. What happens at x equals 2? Well, that means we're taking 2/3 and raising it to the 2nd power, which means that we will get 4/9. 4/9. It's a number slightly less than a half. Probably about down here. On the other hand, if we went to -2, we would get 9/4, which is a number that is slightly greater than 2. And we can continue on in this manner just to see what's going to happen. I'm just going to go ahead and I'm going to type this one in right here. I've got y equals the function 2/3. Let's get 2/3 here. To the power x. There it is. Okay, and I'm going to take this function and I'm going to plot my graph. Oh, my points have shifted a little bit here, but you get the idea. Look at what happens. This is definitely a graph that passes off to the right here. There we go. Just adjusted my graph a little bit so it fits the points that we had initially said, and just exactly what we said. As this is a function with a base that is less than 1 but greater than 0, it decreases as we go from left to right. There is a horizontal asymptote at the point or along the line y equals 0 as we go to the right, and the graph goes towards positive infinity as x tends towards the left, passes through points like 0, 1, here it is, passes through points like 1, 2/3, and -1, 3/2. All right, so once we have the basic graphing style here, it's actually a really easy kind of graph to know. We just have to be careful to make sure that all the points that we're graphing fit with the properties of exponential functions. Okay, more to come in the next video.